Hello and welcome to Functional Skills Maths. Today we're going to be looking at the topic of coordinates and how to use them to specify the position of points on graphs and maps and so on. This is a level 2 topic, and the criteria references for these are 19 and 22, but essentially, as I say, we're going to be looking at how to specify the position of points on graphs, whether that's in a positive way or using negative numbers, and also how to finish off shapes if they're drawn out on graphs as well. This will become clear as we go through. So firstly then, looking at basic coordinate referencing, they're written as two numbers, separated by a comma and enclosed with brackets. So like you see in the example on screen, we have 1 and 6, and this is essentially telling us how many places along we are going, first of all, and then how many places up we are going. So the first number is the horizontal and the second number is the vertical. And they're always written in those brackets as well. So if you want to always remember this, it's quite useful little saying there, along the corridor and up the stairs. So that's just useful to remember, along the corridor, up the stairs. Okay, so having a look at this X on the graph here, we've got the horizontal axis on the bottom, the vertical one going up the left-hand side. Let me just give you a few seconds to have a think about this. What is the reference for that X just there? Let me give you 10 seconds. Okay, did you get that? So going along, first of all, is 3, and then going up afterwards is 4. So we go along, first of all, that's the x-axis, the horizontal 3, and then up 4, 4. And to write it correctly, we have to write these brackets, and we have to use the comma to separate the two numbers as well. Let's do another example. I'll give you 10 seconds again. Okay, did you get this one? It is 5, 2. Well done. And then what about this one here? 10 seconds again. Okay, so this one, hopefully you've got 3, 6. 3 along, 6 up. Now, for a bit more fun, just have a look at these little icons on the graph here. And I'm just going to pause for 10 seconds, but please press pause on the video, give yourselves a bit longer. See if you can find the locations for each of these little images here and jot them down. I'll run through the answers shortly. Okay, your time starts now. Okay, well, that's your 10 seconds from my point of view, but obviously you may have had longer if you stopped the video. So the cup is at 5, 6, so it's 5 along and then 6 up. Boot, feels like a game of Monopoly this, is at 1 and then 5. The dog is quite a straightforward one, 4, 4. The ball, similarly straightforward, is at 2, 2, and the tree also straightforward at 1, 1. And then finally the hat, just to get you thinking again, is 6 along and 1 up. So that's 6, 1. If you've got all of those, well done. Give yourselves a pat on the back. And we're ready to move on, really. So very good, very good. Up until now then, we've been looking at a graph like this, and we've been looking at coordinates in this type of square. So where both numbers are positive. So we've been thinking about how many spaces along we go, and then how many spaces up we go. So it's all positive steps. Now, if we just step back for a moment and zoom out a little bit, we can see that sometimes we're part of a much larger grid. And if we imagine ourselves to be that circle in the middle there, we can see that on this side, where we've been operating and working out so far, it's all positive. But the other quadrants, as they are called, just because there's 4 squares there, quad is related to 4, the other quadrants have negative numbers associated with them as well. So how do we reference these? Let's take a quick look at an example from each quadrant. So as we've seen already, this x is going to be positive on both numbers, and you'll be able to work this one out straight away. It is at 2 and then 3. Now, what if we put an x down here? Well, as before, we're still going along in the same direction. So the x coordinate is still positive. We're going 5 steps along. So that's just as normal. But then we're going 3 steps down. So rather than having 5, 3, what we actually end up with is 5 minus 3. Just like that. Hopefully that makes sense. If we come to the opposite quadrant up in the top left here, we're now going to put an x on this square. Now this time we're going backwards, so we're taking steps back. So this time we've got a minus number on the x-axis. So it's going to be minus 4 and then 2. So positive 2 because we're going up again. So if we're going up from this x-axis, it's going to be positive. And if we're going below it, it's going to be negative. Final one, which is possibly the weirdest, but hopefully straightforward to interpret. If we drop an x into this last quadrant in the bottom left-hand corner, you've probably figured out by now that both of these numbers are going to be negative. So first of all, the x, we're going backwards 5, so minus 5 steps, and then minus 4 steps down. So minus 5 minus 4 is the reference for that. If you need to spend a bit longer looking at this now, then do feel free to press pause and just think about what you're looking at on this screen and what it's sort of telling us before moving on. But otherwise, we're just going to move on to the next slide, and I'm going to put 4 more positions up on the screen, and I'm going to ask you to work them out. So here they are. I'm going to count to 10 seconds on my end. Feel free to press pause just as you're writing these down. Okay, go for it. Okay, so position A is 3, 4. Coordinate B is 1, minus 2. Coordinate C is minus 5, minus 3. And finally, coordinate D, minus 3, 2. If you're happy with that, great stuff. Well done. You're ready to move on. If not, then please have a look at this again, rewind and go through it. Or if you're still having a bit of difficulty, then please do feel free to talk to your tutor who will help you with this. And the key thing, remember always, along the corridor and up the stairs, we're firstly dealing with the horizontal and then the vertical. Okay, well done. The syllabus also looks at the idea of shapes and being able to think about shapes and kind of create them, draw them, plot them on graphs. Really, so that's what we're going to have a look at next. Now, it'd be useful, I think, just to run through some of the shapes that they might throw at you during the exams. Some of them are going to be familiar, and some of them less so, really. So we'll start off with quadrilaterals. It sounds fancy, and not a word that we're accustomed to using probably in day-to-day conversation, but essentially it's any four-sided shape. So this could include things like rectangles, squares, and diamonds, shapes we're pretty familiar with, and then also these types of shape as well, which we'll come to in just a moment. So parallelograms are another category, but they are also quadrilaterals with two pairs of parallel lines. So a parallelogram is a certain type of quadrilateral. So just to get in overarching sense, quadrilateral covers all of the shapes that we're looking at on this page. Parallelograms are just some of these shapes. So they are, in fact, the first three with two pairs of parallel lines. So parallel means running along in the same direction and usually the same length. So these horizontal lines here and the vertical lines on the edges. Same for the square. And again, for the diamond, we have the parallels on the slants. And then trapezium here, which can be applied to the last two types of shape, is a certain type of quadrilateral with just one pair of parallel lines. So we have the parallel lines at the top and the bottom here on this one, where they're running in the same direction. And on the end, we have the vertical lines, which are parallel to each other, and the other ones are differently angled. Okay, moving on to triangles. We've got different types of triangle that might come up. Now, this first one here is an equilateral triangle, and it's all sides are the same length. And as you know, if you've covered the angle stuff, they've also got the same angles within them too. The second one here is an isosceles triangle, and this is where two sides are the same length, as indicated by these lines just running through, these short lines running through the whole lengths. They essentially mean that they're the same length and the same angle. And then finally, we have the scalene triangle, where all the sides are different and all the angles are different too. So these three types of triangle: equilateral is all the same, isosceles triangle mostly the same, and scalene triangle completely different. Anyway, the exams might throw at you questions like this. They might say, look, we've drawn out most of a rectangle, but can you finish it off for us? So find the point needed to make a rectangle. So let me give you a few seconds just to think about that. Where would you put the final X on this graph? I'll give you 10 seconds to think about it. Okay, well, I don't know if you found that tricky or not. It can sometimes be quite difficult to spot when you're trying to draw it out like this. But it would be a 6-3. You draw the lines, and there you end up with the triangle. Sorry, the rectangle. We'll look at the next one. So to make a square. So again, I'll give you a few seconds to think about this. Find the point needed to make a square. Okay, did you spot it? Again, feel free to press pause if you want a bit longer to think about these questions. It is at 2-3. Join the dots and you get your square. Tipped up on the side handily, make it a little bit more confusing. Right, this one here, find the point needed to make a parallelogram. So do you remember what they were from previously? It's where we've got two pairs of parallel lines. So the top and the bottom and the two sides will each match. Okay, let me give you a 10-second time again for this. Okay. It's 4 and 5. And then finally, let's just have a look at this one here. And the point needed to make an isosceles triangle. I'll give you 10 seconds again. Okay, I wonder what you got for this one. There's different options available, actually. So you could have, for instance, 4-4. These two sides are the same. You could have 5-5 or 3-3. You could, in fact, have any point on this line, and that would get you an isosceles triangle. Okay, well done. Well done. If you're getting that so far, you're doing really well. Really pleased with that. That's a lot of coverage of the syllabus points there. Now, the last thing that I want to talk about is the ordnance survey mapping. And this is very relevant for us really in day-to-day life, particularly if we go like hill walking. Maybe you might be a great fan of that. You might already have an understanding of this. You might never have been. You might be thinking about it. Or one day you might go out and take a map out with you when you go and walk up a hill or something like that. Perhaps Snowdon or Ben Nevis if you're thinking of doing the Three Peaks Challenge. But anyway, it also does come up in the exams from time to time. So it's a slightly different way of referencing coordinates that allows us to be a little bit more precise. But it will certainly be useful if you're ever out on the hills and you need an emergency rescue. Anyway, let's have a look at this. It starts off with the fact that the UK is covered by grid squares for mapping purposes. Now, each of these squares covers an area of 100 kilometers by 100 kilometers. And you can see there the country is broken up into lots of these different squares. Some even are out in the oceans. And this stems from the days when it was first all mapped out for military purposes and so on. Anyway, the uses have changed over time to help us map out roads and hills and country walks and things like that. Anyway, each square is given a 2-letter code and is large enough, actually, within those 2 letters to still require several maps to actually cover the whole of one of these squares. So you might have, for instance, half a dozen maps to cover the TL area, or you might have half a dozen maps again to cover the TQ area, and so on. Each one of those maps will then use a 6-figure reference to pinpoint a precise location. So this one here is taken from the TL area. So it's one of the several maps that make up that larger square. And the exact map here is map sheet 154 from the Land Ranger series. And this is a segment of it. This is not the whole map. This is just a segment of it. So you see covering squares 67 to 73 and 34 to 37. So just a small snippet. Now, if we look for a reference using this style, this would be an example here, 685352. We can see straight away the brackets aren't used and the comma isn't there. So if you're asked to find this location on the map, you might be wondering how on earth it even relates to the map. If you're used to the commas and the brackets and you've not seen this type before, then you might be wondering, well, how on earth do we find that? And I would suggest the best way to think about this is to break it down still, as we did with the previous examples of coordinates, where we were looking at just 2 numbers. This one here, if we break it down 3 digits each. So the horizontal axis, the x-axis, has the first 3 digits. So still along the corridor is the first 3. And then up the stairs or the vertical axis, is the second set of three numbers. So that's the first way that we break this longer 6-digit number down. So we now got two sets of three numbers. Now, you might start to be able to get a bit of an idea of where this 685 might be. I mean, you could look at this map and you could see 67, 68, 69, 70. I mean, you might still not be sure, and that's fine. You might say, well, 685 isn't anywhere near this number. That's fine, but you might start to get the idea that 685 could be somewhere around the 68 mark on this map, and you'd be right if so. Because this third digit, we can actually think of it a bit like a decimal point on that 68 number. So if we put some imaginary decimal points in, and we said that this number is actually 68.5, then we could start to think, well, maybe then actually I'm looking halfway in between 68 and 69, and that's the first kind of location of this X coordinate here. It's somewhere along that line. If I just draw that line in there, look, so I'll put a red dashed line in there. Now that line is on 68.5 or 68.5 or just 685. And then when I come to the vertical axis, I'm looking at 352. Well, I could say that's 35.2. So if I come across to the vertical axis here, I'm looking at 35 over on this side. And then 0.2, well, that's not very far up, really. I mean, if 0.5 is halfway between 35 and 36, it's going to be roughly around here. 0.2 then is going to be a lot lower down, maybe somewhere around here-ish. So if I just pop a line across there like that, that's roughly where I think 35.2 would be, or 352. And then what we've got now is two dashed lines on this grid, and they meet in the middle here, round about the location of Little London. So round about there. Just put a little yellow marker on there just to let us know. That there is the location of 685352. And that is how those six-figure references are worked out and used. Okay, we're going to have a look at an example on the next page, and I'm going to ask you to find a couple of different places, shall we say. So I'm going to give you some references, and here's the first one. What's at this location? I'm going to pause for 10 seconds again. Please press pause on your videos so that you can give yourselves enough time to work out what is at that location, and then we'll look at the answer, and then I'll give you another one. All right, so 10 seconds from me, start now. Okay, so what is that TL726351? So hopefully you worked out that it was a windmill. Some of you might have said Gainsford Hall, but if we have a look at this, 726, so 726, so coming just after the halfway line, really, and then up to 351. So here's the line of 35, and 1 would take you just above it. So right about where this little icon is, which, if you didn't know, that's a windmill, house with the X on the windmill. Yeah, the next one, have a go at this. What is that? TL701352. TL, by the way, is just because this is the larger square that we're in on the UK mapping system. So let me give you 10 seconds again. Okay, did you get it? So 701352. So 701, well, here's 70. 1 is going to be just ever so slightly past that, around about here, let's say. And then 352. So there's 35 and 1, 2, which takes us up to this little building here, which we're told is Mill Farm. So Mill Farm is the correct answer for this one. One final one for you to have a look at, a little bit more chance to practice, is 683365. Okay, 10 seconds again. Okay, and then this one, so 683, so here's 683 is, well, here's 5, so it's going to be just by that little blue line, which is a river. That's 5, so 3 is going to be somewhere around about here-ish, 683, and then up to 365, so that's 35, there's 36, and halfway up to the next one, 7, so we're somewhere around this little building here, which is a church. So that would be the answer for question 3. Okay, this one can sometimes take a little bit longer to get a hold of. So if you need to look through this section again, please do. And if you still need a bit of help, then do ask your tutor, who will be happy to help give you a bit of clarity on this. Okay, but thank you for joining me. And just as a recap, today we've looked at how to use coordinates to specify the position of points on graphs and grids in both positive and negative quadrants, really, sort of any of those 4 different quadrants. We've also looked at being able to complete shapes of different sorts, different kinds of triangle, different types of quadrilateral, and being able to plot those and map those on graphs. And then finally, we're going to look at the Ordnance Survey mapping system, which is the one widely used across the UK to locate precisely positions on actual maps. So yeah, well done. Thanks for joining me, and all the best with your functional skills course.